But one of the most fundamental configuration elements, starting with 941, is you have a roles table, orchestrated role mapping table. Roles have really just two things that you configure. You configure the name of the role. So you can see here we have a role called guests, contractor, employee, and then you configure the GPID. Now I've right-click and unhidden the fabric ID column. This column's hidden by default. You won't normally need to know this, but I want to point out what the fabric ID does. So I've unhidden it to show in these examples. So this role mapping table is being pushed to all the EdgeConnects. Now this makes a core assumption that all EdgeConnects, all branch locations have the same GPID mappings. It's very important that you map this appropriately in Central, in ClearPass, and in the SD-WAN fabric. We'll talk a little bit more about that later. All right, so let's talk about how it works. So imagine employee 1 here wants to connect to user 2, or user 1 wants to connect to user 2. So on the left, user 1 802.1x authenticates against the switch and gets the role employee. The switch will then have a series of configurations that will map the employee role to a GPID. This is configured in the Fabric Wizard. Actually, it's configured in the security node of the global section of Central Classic. If you want to right now, you can go see this, go to global, and then click security, and you'll see that there's a roles button. So you configure the GPID to role mapping in Central. That allows the CX switch to send the packet toward the EdgeConnect across the VXLAN tunnel with GPID 2010. So that means the EdgeConnect is going to receive an Ethernet frame with a header on it that has GPID 2010 in it. So the EdgeConnect will look in this role mapping table and it'll say GPID 2010 right here. So that's the employee role, and that maps to fabric role, this is our sort of normalized fabric role 14. So the EdgeConnect will put that role information, that encoded role information, the source role 14 in the tunnel packet itself, like in the actual header of the tunnel packet. To transfer it across the network to the EdgeConnect here, the other EdgeConnect receives it, and it does the reverse. It says, all right, source role 14, it now knows to send that packet toward the LAN side VXLAN host with the GPID of 2010. So this is fundamentally what we've done, is that we automatically transfer the role context, the role GPID information from one end of the fabric all the way to the other end. It will survive hairpins, so you can route across regions like spoke, hub, spoke. That's fine. Hub and spoke. In all these situations, we always preserve the GPID. So once it gets to the other end, we go to user 2. User 2 then responds back. The 802.1x or MAC off on the other end. The role that's derived is contractor. So now the thing starts in reverse. So now the switch sends a GPID of 2020. The EdgeConnect encodes that. Source role 13 sends it to the other side. EdgeConnect on the other end unwraps the tunnel packet, finds ID 13, tags it with GPID 2020 on the other side. So in this way, we have completely we've established this GPID context all the way across the whole fabric. Why this is important is because it allows you could be in Central, you could be in the EdgeConnect orchestrator, could be in any system really. And you say a very simple primitive thing. I want to allow employee to talk to contractor. Just that's it. Employee can talk to contractor, permit. It's not like I'm talking about proprietary constructs. It's not things. All of the Aruba products understand this language of roles. So now you can see I got like purple lines. This role that's being asked for can be invoked here, 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 and here in the same way in each situation. So each one of these devices understands the language of roles and will be able to invoke an employee to contractor policy in their own way. It does not matter what identity pipeline is on each end. That means you can mix them. So you can have VXLAN on one side, like at your branch, and you can have radius snooping at another branch, or you can have VXLAN in the data center and you can have radius snooping at the branch. You can have snooping at one place and snooping at the other. Let's look at why that is. So in this case, we've got a user over here. .1x authenticates employee. Same thing. We just VXLAN, GPID, Aruba equipment. We encode the GPID value, send it across the fabric. Now, when it gets to the other side, though, there's an Arista switch, no VXLAN. What do we do? Well, when user 2 authenticates and connects to the network, we snoop the fact that this user is using role employee. So this here gets mapped into this record. So now you have this EdgeConnect does a lookup on the actual name. Case sensitive, very important that you have precisely the same role name there. So if we snoop employee uppercase off the wire, you need to have employee uppercase configured in this roles list that you see at the bottom of the page. So now from this point on, it's all normalized. We know it's employee, so we encode source role 14. When it gets to the other end, this is where the magic happens, I think. We map something that was originally snooped as text off the wire employee to a GPID value on the other end that is interpreted by the CX switch. So the CX literally does not know that something like this is happening on the other end. It thinks another VXLAN GPID thing is occurring. It cannot know that on the other end there's another mechanism building and sending the role information. You don't even need, you could just have anything you want on either end, as long as you're not using RADSEC. As long as we could snoop the radius, you can do what you see on the screen here. You can have full role-to-role policies in the EdgeConnect without any VXLAN, for that matter. See how this operates? Mapping contractor, employee, same stuff, same thing. It's the magic of this normalization, this mapping and normalization mechanism that we do across the fabric that makes this so powerful. Now let's talk about one quick technical bit here. Imagine that employee sends a packet toward the CX. CX encodes GPID 2010 for employee. We send it across, well, actually stop right here. This EdgeConnect, what is the destination role at this point? Like how can this guy perform a source to destination policy match? It can't, because it doesn't know the destination role yet. What we do is we just leak the packet. So this EdgeConnect here says, oh, okay, source role GPID 2010, which is employee, destination role don't know yet. So it leaks the packet. Go ahead and forward the packet to the other EdgeConnect with the assumption that the other EdgeConnect will make the final decision. So now when it comes to this EdgeConnect though, look at the problem here. It's got the same issue. Like what does it do here? This EdgeConnect does not yet, most important part, this guy's offline. He's not sent any packets at all, and he's not responding to packets. So when this packet comes inbound to this EdgeConnect, what is the destination role that this EdgeConnect will use? Well, it's still unknown. It doesn't know yet. So the EdgeConnect will let it leak. It will leak GPID 2010 because that's the source role. It will send that packet toward the offline host, and the offline host will just not respond, or we'll get a host unreachable from the switch or router or whatever, but we will never get a response back. The EdgeConnect will just continuously allowing these, what are essentially our failed connection attempts, to that device, because we can, until this device responds back, we will not know the source role, because we need to see at least one packet that has the source GPID in it, or we need to snoop something. But we literally can't know what the destination role is in this situation, so we allow the packet to leak through. So this is an implicit leak. So this will happen automatically without you really having to do anything. Now you can turn off this implicit leak. There's a button that we've added to the zone-based firewall policy, allow unknown destination role. It is checked by default. Most situations you're going to leave this checked. If for some reason you want a really tight config and you can uncheck this and it will disable that leaking mechanism. Imagine a wake on LAN device like a printer. It's not offline, but it just only sends packets when you send packet to it. Well, same thing would happen there. We need at least one packet to get to the printer so that it can respond back, so that we can see the GPID value in the response. Then the very moment we see a response packet, we immediately do a policy lookup. And if it's a deny at that point, if we see, employee is not allowed to talk to guest, so we no longer leak, that flow goes into drop state. The moment we have enough information to make a complete source destination decision, we update the policy and begin dropping or permitting the flow. A couple kind of quick notes on this. Yeah, the leaking can be disabled using this checkbox. It's enabled by default. This implicit leak functionality only applies to security policies in the context of the firewall. It doesn't do anything anywhere else. It kind of doesn't make sense anywhere else because you can't wait to decide what the destination role is for like a overlay ACL, because by the time you get to the other end, you're already in an overlay. You can't, so we only do this implicit leaking thing for the security functionality, the zone-based firewall policies. And kind of importantly here, because you might say, well, Adam, what about for the internet? What if I just start pinging a random internet host and never responds? Am I leaking packets to the internet, constantly? The answer is no. It will not ever. This implicit leak never applies to hosts that are internet hosts. In other words, the opposite of the internal hosts list that we configure. Some additional notes. Yeah, internet destinations are always assumed to be unknown. So if you look in the policies, you'll see they're always unknown as opposed to default. It's a subtle difference. Default means is GPID 0, and that means we didn't set a GPID value, but we had a source pipeline to look at. Unknown is slightly different. That's where we literally do not know what the source role is. If we receive a GPID number that has not been configured in the mapping table, this is what will happen. Let's say you misconfigured that table, the employees misspelled or one of the GPID numbers is wrong. We will fall back to the default VNI role, which is configurable. Same thing for radius snoop packets. If in radius snoop packet situation, if we snoop the name employee and is lowercase, and in the role mapping table you've configured employee as uppercase, it will not match employee. It will fall back to default. So what you see in the columns in 941, and what you see in the flow table is what we're matching in the policy. That's very important. Like if it says, if it says role default right here, then that means that's the destination role that we matched in the policy.